Hello everyone, welcome to Internet Programming course in this semester, Spring 2021 at EHA University. I'm Sarwar Abdullayev and I'll be your instructor in this course. I hope we're going to have a lot of fun doing web programming in this particular module. So first, let me go and explain you certain course logistics for this course. As I said, I'm your instructor, and here is my email address. And this is the most preferred way of communication with me. If you have anything to ask, please don't hesitate to send an email to this email address. And I'm usually very quick to respond back. So it may take most 1 or 2 days. But if you still want to have a real face-to-face talk with me, you can always pop in to my office during the office hours. And this time schedule is for the current timetable that we have, but it may change if the timetable also changes. So if there's any change, I'll of course update you about that. Okay, and my room number is in B campus. It's B411. Okay, so what is the format for this lecture, for this course? We are going to teach this particular module in a hybrid mode. So I'll be recording the lectures every week, and I'll try to make the length of the lecture about 1.5 hours. And after that, you will have 1 hour offline lab session. Okay, in the lab session, you will be doing the exercises related to the topics covered in that lecture week. Okay, so this is my Telegram channel. I want you to subscribe to this Telegram channel because at this moment, I'm going to use the Telegram channel as the main platform for our communication. So I'll be updating all the lecture slides and then the lab assignments, and also post the lecture video links to this Telegram channel. So please get subscribed and then get all the updates from this Telegram channel. Once we have our learning management system, LMS, ready, we'll start using that as well. Okay, so I also created a playlist for the videos. This video will be uploaded as a recording in this playlist, so you can always get all the recordings in this playlist for a particular lecture. And I also created a GitHub classroom for our labs and projects. So every week you're going to get an invitation link from GitHub Classroom to which you have to respond. You have to go and accept the GitHub assignment and then start doing your assignment. Of course, I'll be helping you doing your lab assignments in our offline lab meetings. Okay, so let's talk about the assessment. I'm going to calculate your grade. As usual, the two major assessment components are midterm and final exams. They're going to make up 30% each, so 60% in total. And the midterm is going to cover the topics of the second half of the semester, and the final is going to cover the topics of this. The midterm is going to cover the topics of the first half of the semester, and the final exam is going to cover the topics of the second half of the semester. So these are, again, tentatively the weeks from 1 to 7 and weeks from 9 to 15. So the semester is going to be 16 weeks long, right? And we know that the midterm and final are going to be in weeks 8 and 16. Other than that, you'll have a group design project. It's a group project. In this project, you should be designing your project with your team. And I'll give you the specifications of the project after the midterm once you're ready to start your project. And it's going to make up 20% of your total grade. Okay, so other than that, we have two more assessment components. It is the in-class quiz. So in our lab meetings, I will take quizzes as well. and I can take unannounced quizzes as well. So just to make sure that to understand how well you're catching up with the covered topics. And during the semester, I might take at least 2, but it can be more. Okay, so and I'm not going to announce the time when I'm going to take the quiz. And that is the reason is that I want everyone to be in the lab. And if you miss the lab, if you were, let's say, absent during the lab session and I took the quiz, you cannot retake that quiz again. So your absence might cost you a quiz. So please be very, very careful and try to participate in all our lab meetings. Okay, that's kind of one extra motivation for you to, if you don't want to like lose your points for the quiz, obviously you should be attending every lab meeting. Okay, so hopefully that's not going to be a problem. And the last one is the attendance and the lab participation. So I'll consider both as the same. Why? Because like you come to the lab and then you have to start doing your lab, and basically that means you should accept my GitHub Classroom invitation and then start doing your work. And then at the end of the lab or by the deadline, every lab assignment will have a deadline. By the time the deadline arrives, you should submit, you should push certain changes into your repository. So the GitHub Classroom will create your dedicated repository for your lab, and I have to see something done there. Okay, again, whatever you did there is not particularly important. You might do things wrong, or you might, let's say, copy it from your friend. By the way, you are allowed to collaborate in the lab. Okay, it's important, so you can share your whatever you know, your answers maybe. Okay, as far as you go, I mean, as long as you go and do something in your lab and then try out or reproduce the solutions on your computer, that will suffice, because like this way you're gonna learn, and this way you're gonna try it out yourself and see what's actually how it's working, and then it basically gives you some certain idea. So I would rather say there's no other good way of learning programming, especially the web programming, other than just trying it yourself. That's why I'm just okay with that. Basically, this is the only assessment component, I would rather say, where the cheating is allowed. Okay, and it's not just allowed; it's encouraged as well. So you just need to kind of help each other, okay, collaborate, and then submit. And then if I see something done, okay, I will consider you as participated in the lab, and obviously, at the end of the semester, I'm going to count how many labs you participated and going to draw the points for your lab participation from that. Okay, so it's very important to do something in the lab and to make sure that you push it to your repository. We'll talk about how to do all that stuff, okay, the technicalities in a separate video. I'll create a separate instruction video for you to get your assignment from the lab and then make changes and then push it back to your repository. So if you're feeling a little bit confused about that, no worries. There will be a special instruction video on that. Okay, so the lectures are going to be very, very practical, and so what I want you to do when you watch these lectures, I want you to reproduce the lecture examples on your computer. Okay, after watching them, obviously I will be sharing all the lecture examples, okay, after the lecture, so you can go and try out those examples on your computer and make sure that they work on that computer. Okay, so this way you will understand everything in the lecture and also kind of get your a certain handle on how this particular programming thing works. Okay, so also the lab assignments you should submit them individually, and you're free to collaborate, as I said earlier. So the course overview, what are we going to study throughout this semester? Okay, so in the previous sessions I asked a couple of you in the group, not couple of you, the entire group, by the way. I asked who knows the basics of the HTML, and it was like 20-30% of the group. So I hope for the majority of the students, this particular, even the beginning of this particular class will be very, very useful. So, but in general, how are we going to study in this semester? First of all, in this lecture, in the lecture 1, we're going to discuss about the internet infrastructure and the basics of the HTTP protocol. The HTTP protocol is considered to be it's an application layer protocol, and it's considered to be the main protocol for any web application. Okay, so any web application uses this protocol to transport the messages, and then send requests, and then process the responses. So after talking about the HTTP protocol and trying to understand every piece of it, we will switch to a series of lectures on the basics of HTML and CSS. So we'll discuss about how to build a simple structured HTML document, and then we'll talk about how to format our HTML document using CSS, and how to make basic layouts using CSS, and so forth. So I think we're gonna spend 2 or 3 lectures on this particular topic again. So I think hopefully it will be very useful for those who have no experience with HTML or CSS at all. Okay, so starting after that, finishing the HTML and CSS, we'll talk about the server-side scripting languages, and we'll start with the plain PHP. So PHP is a very common and easy language to learn, and it's very popular among web developers for the server-side programming. So we'll start getting our way to the server-side programming, and we're going to think about what is the server-side programming and how we can go and use a scripting language like PHP to develop dynamic pages, a simple, not just a static page like HTML, CSS, but some dynamic pages that can change, okay, depending on a certain context. The context can change the content of our web documents. We also use database management system. In particular, we'll talk about MySQL and how to connect our PHP scripts to this MySQL database management system. We're going to talk about those things as well. Okay, so this 4 major topics will basically conclude the first half of our semester. So it will be these topics will be covered before the midterm. So after the midterm, we'll get our way into the world of frameworks. Okay, and then we start our first framework, the server-side programming framework, which is written on PHP, the Laravel. Laravel is a very popular framework among, again, web developers. We'll talk about what is a framework in general, okay? So how it's different from particular, let's say, a component or a utility or something, okay? What frameworks usually offer to you, okay? And what kind of architecture they bring to your design. And so as an example, of course, we'll use Laravel to illustrate you the capabilities of a framework and why developers so like these kind of frameworks, and why the frameworks help you to build applications, web applications, or any type of applications very quickly. Okay, so this kind of discussions will be made after the midterm, and so we're going to maybe spend 3 lectures on that, on learning the basics of Laravel. Okay. And after concluding with the Laravel thing, we'll switch to the client-side programming, client-side scripting languages, and we'll start with the JavaScript, the plain Java, vanilla JavaScript. And we'll talk about why JavaScript is there. Okay, what is the purpose of? What was the first purpose of basically including JavaScript into the browser, and now what is its current role? Okay, so we're going to talk about that, and then we're going to try out simple programs using JavaScript, simple JavaScript. We're going to learn some new concepts using JavaScript. And then we'll switch to, at the end of the semester, hopefully, we'll switch to a client-side programming framework. It's a different framework. It's a JavaScript framework called Angular. And again, we're going to talk about the basics of Angular, okay, how you can go and build a client-side application, not a back-end application, but a front-end application using Angular. Okay. Other than that, beyond these topics, we're of course going to cover some theoretical and things, the concepts like cookies and sessions, and we're going to talk about what is an authentication, or how the AJAX works, or how to build web services and APIs. Okay, using the backend frameworks, and we're going to talk about the features, the new features of HTML5 and CSS3. We're going to talk about transpilers like Sass or TypeScript, right? So the TypeScript is not included here, but we're going to talk about these kind of transpilers and what are their role in the web development. We're going to talk about the differences of ECMAScript 6 and many more. Okay, so there are a lot of different things we're going to learn in this semester. And again, if you think that this like bag of words seems to be like something weird to you, don't worry. Hopefully by the end of the semester, you're going to have a good understanding of these concepts, right? So again, my hope in this particular semester is, okay, so by the end of this semester, you will somehow be, let's say, 1 or 2 months short a junior developer. Okay, so a junior web developer. Let's be very specific. So again, it's not something that at the end you'll kind of can call yourself a junior developer. You will still need a little bit of an experience. So if we finish this semester like at the beginning of summer, so and then you devote your summer for a let's say a summer-long project, and then you work on that project and you release that project. Okay, at that point maybe you can surely call yourself as a junior developer, junior web developer, and maybe apply for a position in some company. Okay, so again, this is mostly about learning things, but after learning you will need a little bit of an experience too. So this course is going to give you the knowledge, but maybe you're going to go and get the experience on your own, okay, after finishing this semester. So regarding the core textbook for this particular module, I would rather say we don't have a core textbook in this course. Why? Because first of all, the technologies change very fast, and even if we had a course book, textbook for that particular module, it's going to be very, very big, okay? Because it involves like a big mixture of different things. But if you're an absolute beginner and you just want to know the basics of HTML and CSS, for the first half of the semester at least, we will be kind of orienting ourselves to these two books. So I recommend you to first start from this book, and in this book you're going to find the basics of HTML and CSS, how to go and create simple web pages, and we will be kind of organizing our lectures according to the content given in this book. You can find this book in our university library, and I think we have the access there for the electronic version as well. Okay, I'll try to ask, and then if I can find, I can share it with you too. So there's also another book which is also useful. After finishing this book, when we start talking about PHP and MySQL and JavaScript, maybe we're going to learn the rest of the concepts, the basic concepts, fundamentals from these books. Okay. So again, if you're kind of an absolute beginner, I recommend you to start reading these books, and then at least for the first half of the semester. And then after that, we will be learning new things and referring to the official documentation of the technologies that we'll be using, okay, in this course. So if we're going to use Laravel, then we're going to refer to the Laravel's official documentation. If it's an Angular, then we're going to refer to Angular's official. If it's a TypeScript, then we're going to refer to the official documentation of the TypeScript. Nowadays, these documentations are not very, very technical. Yeah, back in the old days, documentations were very technical. People could not kind of interpret the documentation the right way. That's why people use textbooks. Okay, nowadays documentations are much better than textbooks, and they keep updated all the time. If you go and check the documentation, most of these technologies, other than just having a kind of a reference API, something like that, they also provide you a good number of tutorials for getting into this particular framework and then try to understand its concepts and so forth. So obviously we're gonna kind of explore those things, okay, in the course of this particular module. Okay, so now let's continue. Yeah, so also you're required to install a certain number of software on your computer if you want to use your computer to engage in this particular module. But okay, we'll be doing labs, and then you will have our lab computers also available to you for doing the exercises. Okay, so first of all, we'll need some server-side software. I gave you all the links here, but we will be installing all this software, okay, upon our need. But so you can go and install them if you're by yourself as well, because this installation of these programs is straightforward. You can have a graphical GUI installer, which is even easier. So you can go and download those things. We will need XAMPP. XAMPP is some sort of a bundle which helps you, which basically contains a web server, the MySQL database management system, and a PHP interpreter. Along with that, it also contains Perl, but won't be using Perl in this course. The Node.js we will be using as an interpreter. It's a JavaScript interpreter outside the browser. So normally we see JavaScript inside the browser, but we have Node.js. It's something that we can run as an interpreter on our computer, and we need Node.js to run some npm modules, npm utilities to build certain things for browser. Okay, for client-side programming, obviously. Okay, so we're going to talk about so we're going to also need the IDEs. Okay, there is the PHP Storm and WebStorm. These are the JetBrains products. There are free versions of these products, and the community version it's called. And this community version is basically like 80% fine for us, unless we are kind of using some database connections or something. But you can also apply for a free student license as an Inha University student. I gave you the URL here. Go and click this URL, and then you're going to find a form there. You just need to fill in the form and get the free license. Once you get that free license, you can, let's say, download the Ultimate Edition of these two IDEs and then use them, okay, with this license. Okay, so you're going to get 1 year free license from JetBrains for using this particular product. So I urge you to go and apply for the student license and get your free license to use these applications. These are very, very powerful applications, and it will be very difficult developing a web application without these. So at the beginning, we're gonna use maybe Sublime. Sublime is free. It doesn't take. I mean, it's not kind of officially free, but you can use it for free. Okay, so you can go and download Sublime 3, and then for your basic HTML and CSS editing. But once we move to PHP and Laravel, we will need PHP Storm, and we'll also need a WebStorm to do our client-side programming. So we'll need two IDEs here in this in this module. Okay. Also, you will be using Git for our version control and doing our tasks. So I'll give you a separate instruction on how to use Git to clone your repository and then to push your completed task back into your repository. Other than that, we'll talk about curl, Postman, Composer in our labs, and once we go and work with these software, okay, utilities. Okay, fine. So now let's go and start our first lecture in web programming. So in this particular lecture, we're going to talk about the basic infrastructure of web and internet, and then we'll talk about the fundamentals of HTTP protocol. Okay, so and we'll just get the distinction between the client-side and server-side web programming. So what is internet? Yes, what do you think? Is it just like something that you open in the in your browser, or is it Google, or is it just YouTube, or whatever application system you use. Of course, internet is much more than that, right? It's not web. Okay, so you just need to understand the difference between the internet. Okay, internet is just the international network. Okay, the global network of computers. So we have a really big network of computers connected to each other, and through this network we can basically send anything we want. We send our emails through this network. We're gonna send we download files, right? So we send videos and everything over this file, and not necessarily everything should be sent through web, right? Imagine you're using internet using your mobile phone. Okay, so in the mobile phone you got some mobile application, and your mobile application makes a different type of connection with the other computers or with other mobile phones, right? So of course through the network. So, and they are not necessarily using web for their communication, right? So web is just a small part of internet. For example, you use Skype, right? So Skype also uses internet. You use Zoom, right? Zoom uses internet, and they don't use web. They use internet, because the network that connects these computers to each other. So you just need to know that this internet has been actually, as I said, is the collection, is the network of computers. But these computers they make themselves a small local area networks. These local area networks are combined into some, are joined to the global network through a local internet service provider. The local internet service providers are also going to make a network of regional internet service providers, and the regional ones, they just connect to the world providers, right? So a world network. So this way, you're going to see that there is a small hierarchy of networks here, but at the end of the hierarchy, you're going to find your computer, your home computer, or your work computer that is connected to the big vast network. So as I said, the World Wide Web, or 3W, sometimes we just call it web. Is it the same as the internet? Of course no, right? So internet, as I said, is just a collection of computers connected through a big network, and the web is a particular aspect of it. We're going to talk about web later. So this is a very quick history of internet. Let's not focus on this. This was basically, and perhaps you already know that, this is a project of a US DARPA, as an ARPANET, and then it was basically done to make sure that if in the case of a certain disaster, catastrophe, there will be a communication network in the US for that would do a packet switching communications. A packet switching communication means the data decides which path. It's not the caller or the sender decides which path to choose, but the data itself can independently choose its path to travel. Which path? There are a lot of different ways the data can travel through the network. And when you're creating a connection, it's not the human beings are choosing the which connection to which line to occupy, but the data itself makes this decision to choose its own path through the network. So that is kind of the basic of it, packet switching. And then we got the applications that came to use that we use the internet. The email came earlier, much earlier than internet, than web as well. And then so we had all these things, and then in 1991 the first web page has been created. The web page is basically let me give you a good definition of web then. Web is a network of web documents. And these documents, they are stored in our computers. So now, like, the internet connects computers, but now our documents could be connected to each other as well, right? So let's say I got a web document in my computer, and this web document refers to other web documents, right? So, and these documents, they all refer to each other through the notion of a hyperlink. So we got a hyperlink, right? So the hyperlinks in our documents refer to another document, and this way they are making a web of documents, right? And this web of documents we shortly call web. But nowadays, these documents, they are kind of virtual documents. They sometimes, if it's a dynamic document, doesn't exist. It doesn't even physically exist. They get created on the fly. But the point of the notion of documents referencing other documents over the internet has been actually proposed by Tim Berners-Lee, and he actually the one who created the first web document that referred to other web documents and so forth. And then soon after the vendors like Netscape and Internet Explorer, they came to they merged, and then what they did is they helped you to navigate from one document to another document with a very ease. Okay, by just click of a link, now you can go and navigate from one document to another document. And then also you're going to see the entire document in a user-friendly way. Okay, it's not just like something that looks like it's plain text, plain and bland text, but it has the title, it has images in it, or it has certain formatting in it. So the browsers were able to help you to navigate through these documents. Also, they help you to render the document into something like this. Okay, so these were the purpose of the early browsers. The browser were basically a reading application. It's simply like a reader for your web documents, and then everything got out of the Pandora box. The Amazon opens its first electronic shop in 1995. Google actually creates its first search engine in 1996. Wikipedia launched in 2001, and then MySpace, but now it's a dead project. But Facebook actually starts off in 2004, right? So these applications nowadays, we call them applications, where first of all, Google helped initially to find the document in this web, right? So they got thousands of documents interlinked like this. So how you're going to find the document that you are looking for? Google invented their PageRank algorithm to help you to find the important documents in this web. Those documents that are referenced by many more other documents were considered to be more important, and therefore Google actually ranked them higher compared to other documents, right? So they were basically coming out with this new utility that helped you to find the document in this web. Amazon used this document not just for searching, but it's just for selling items in this thing. It's okay. So people were not using the documents to learn something new, but maybe you can go and do some e-commerce on that thing. So these were all innovative ideas. These were like things that were surpassing the initial use of web that has been, let's say, originally proposed by Sir Tim Berners-Lee. Okay, so nowadays we have a completely different world, and the web has a completely different purpose. It's not just merely a web of documents. This is basically a different world which offers you enormous number of services through which you can actually do nearly everything today. And we're going to talk about how to build such services that could be delivered over web. To humans, maybe to computers as well. So this could be perhaps the future of what we know today. So again, I'm going to talk about, I already talked about the internet aspects, and then there are certain bodies, people, organizations that are involved in controlling the standards and the use of certain resources in internet. For example, the ICANN is responsible for distributing domain names, at the top level domain names to certain countries, basically they hold a one big DNS root. We're going to talk about that in the next slide, but the point is this organization is a regulating organization, and it's not owned by a particular private company or a government. It is a non-government organization, and no one can go and make an influence on them, but they can go and make decisions on which ranges of IP addresses map to which top-level domains and so forth. And they basically maintain the register by themselves too. The World Wide Web Consortium is another organization which is responsible for developing web standards, like the languages like HTML, the CSS and JavaScript, all the language, the syntax, the things that they should do, they meant to do, okay, are specified in these standards. And the web browsers, the ones who implement those web browsers, the vendors, they have to accept these standards to make sure that any web document actually gets rendered and that behaves correctly in their browser. So they kind of comply with the standard, okay, in order to make sure that their browser is compatible with all the web documents that are available in the web. So these are kind of organizations that are important. There's also IETF, which is responsible for developing Internet protocol standards. It's like the TCP/IP and the TCP/IP suite, which it's called the TCP/IP suite because it contains a lot of other protocols that are used on different layers of the OCI model. So again, this is a little bit beyond the topic of this particular module because we are not talking about networking in general, but I showed this particular layered architecture to indicate the position at which we will be working. So you're going to see that there is an OCI model for this internet communication, starting from physical layer to the application layer, and every layer has its own particular responsibility. What we'll be doing is we'll be working on this layer, in this application layer, and the application, and we'll be working with one particular protocol that works on this application, and this protocol is called HTTP protocol, right? And we will ignore other protocols. There are other protocols like SMTP, for example, for sending emails, right? There's POP3 for receiving emails, IMAP for receiving emails, but with more features. There are many. The FTP for transporting files, right? So there are a lot of different application layer protocols, and every application layer protocol has a particular purpose. We will not discuss about these protocols. We will discuss only one particular application layer protocol called HTTP. And on this layer, the application level protocols, they have a particular purpose, right? So they do a particular job, and they specify how to communicate between two computers, between two programs, in order to accomplish that job, okay? So SMTP has one single job: send an email, right? So how to transport the email, or how to relay the email, okay? Because sending email means relaying it from one node to another node until it reaches the destination, right? So how to transport or relay the emails, okay, all the specifications are written in the SMTP protocol, and the vendors, the programmers like you and me, should implement this protocol, the logic, to make sure that for example, email gets propagated over the network. Same thing works for HTTP. We as programmers need to understand the HTTP protocol and then try to kind of understand what is involved inside the browser's logic or inside the web server's logic in order to understand how this web infrastructure actually works. So we're going to look into this HTTP, the anatomy, and we're going to understand what exactly is involved in that. Okay, good. So internet IP addresses, I think pretty straightforward. Every node is up in the network is identified by an IP address. It's in IP version 4, it's a 32-bit identifier. We usually write it like this with four digits, okay, from 0 to 255, or so you can consider that this is like 8 bits, okay, 1 byte each. So this is a 1 byte, this is 1 byte, this is 1 byte. Bytes can be expressed as numbers, it's like integers from 0 to 255. They can be expressed in terms of a hexadecimal digit. In this case, it will be a 2 two digits, two hexadecimal digits, right? So what two hexadecimal digits make up 1 byte, right? So sometimes you might go and use that this way as well. So if you look into the IP version 4, this represents the domain or the subnet, and this represents the host, the particular one concrete IP machine, okay, in that particular subnet, right, in that particular network. Okay, so this is the address of the network, and this is the address of the concrete host, of concrete computer, this one. So all together, we can find one particular unique computer in any network, and this IP address can uniquely identify a concrete computer, okay, in this network. In the IP version 6, okay, this is not enough nowadays. Got more than, like, this is going to make what, 2 to the power of 32. It's about, I think, 4 billion or something, right? So 4 billion is not enough nowadays to make sure that every computer can get a unique IP address. So people came up with IP version 6. In the IP version 6, we have much more bits to store the address, and this is actually even more. This number is even greater than the number of atoms, I think, in the universe or something. At least for that, okay. So, and obviously that will be enough. This address space will be enough for us to assign every node in the network with a unique IP address, and we basically go and use this like with hexadecimal digits, okay. So this is kind of the Internet of Things, for example. They use this version of the IP protocol, but most of the world currently is using this one, but we're transforming to IP version 6 slowly but steadily. Domain names, okay, we humans, okay, in order to identify a computer, again, we need to know its IP address, right? But we humans cannot remember the numbers very easily, okay? I mean, it's very difficult for us to navigate through these numbers, okay? We need something like something human-like, something mnemonic that we can go and remember easily. So that's why we need domain names. The domain name is something that maps something human-readable text into some IP address, and for that we'll need to go and run a special application called a DNS server. The DNS server is an application that runs on some computer, and what it does is it maps, okay, your mnemonic addresses to your IP address, to the IP address that is represented of the computer that is represented there. So we have top-level domains. These domains, like the endings, like .com, .uz, and as I said, ICANN is the responsible body for managing these top-level domains. There's a domain name server which is responsible for mapping the mnemonic addresses, the names, domain names into IP addresses. There's one thing that you need to know: there can be multiple domain names mapped to the same IP address, so this means that, okay, you can host multiple websites in the same computer. So that is also possible, and nowadays this is how is most things done today. So you can have the same website in the same computer, multiple websites in the same computer, and have multiple domain names referring to that computer. That's fine too. Okay. So how we gonna read? Okay, what is the URL? URL stands for Uniform Resource Locator. It contains information about the position, okay, the location of a particular web resource. Okay, so for example, there is a document, okay, somewhere in some computer. How can I go and find that document over the web? Okay, so there is a nomenclature for that. So the nomenclature is represented in this format, in the URL format. So this represents the protocol. Okay, which protocol you're going to. Okay, if you're trying this kind of uniform resource locator, you're telling a lot of things to the program that is meant to, let's say, get this particular document to your computer, transport this document from a remote computer to your computer. First of all, you have to specify which protocol you're going to use to transport this file or this resource to your computer. Okay, so you're going to say, okay, I'm going to use HTTP protocol. HTTP protocol is kind of a media agnostic protocol. It can transport any resource back to wherever you want. Then you're going to specify the domain name. This is the domain name. Domain name represents a particular IP address, and the IP address represents a computer. Okay, some computer that is okay that holds that file. Okay, and then you go and specify the path in that particular computer, the virtual path that kind of leads you to the particular location of this resource. This is considered to be the path, and then this is considered to be the file name, the actual name of the resource that you would like to download to your computer. Okay, so yeah, the World Wide Web, we talked about that. The website is a collection of web pages that have a common theme and share the same domain name, right? So if someone else asks what is a website, okay, you need to have a good definition for that. As a web developer, it's just a collection of web pages. Okay, what is a web page? Again, it's a web document, something that we can download, okay, from the web. Web page is something like a node in the web, what we call web, right? It can contain text, it can contain graphic images, it can contain hyperlinks, and many more resources like music and so forth. So it's any resource that is interconnected inside the web. But what is a website? Okay, website is just a collection of web pages. Okay, and then what unifies this collection? Okay, it's got the common theme and the domain name, which unifies them together. So that is kind of called a website. And every website has its entry point. Okay, so its home page or index page. Whenever the user goes and types in the domain, a domain name into the browser should go and get the home page or the index page of that particular website. So the entry page, and that page normally contains links to all the other parts of your website. Okay, what is a web server? Is it some sort of a hardware like this, okay? Or it is something more than that, or it is something less than that, okay? Many people confuse themselves calling this kind of things like big shelves or racks, okay, as web server. Okay, this is a server. I know it's very serious, very kind of very frightening, right? But the point is, this is just a piece of computer, a piece of hardware. Okay, it just can run anything you want in it. Okay, so don't call this thing as a web server. If you go and call this as a web server or any computer that is bigger than your desktop computer a web server, that is naive. Okay, so don't do this. Web server is just a software, and you can run it anywhere you want. You can run it on your computer. You can run it on a big computer, mainframe computer like this. It doesn't matter where you run it. Okay, it has one single job. It has to serve your web documents. It has to understand the HTTP requests sent by the browsers and then send the resources that are requested by the browser back to the browser using, again, the HTTP protocol. That is the only job of the web server. Okay, this is a simple software which basically understands HTTP and also has access to your computer's local resources. So you can go and get the content of your file and then send it over HTTP. Okay, there are a lot of different programs that can that are web servers. Okay, Apache 2 is one of the most commonly used web servers nowadays. If you're using Microsoft, then like .NET, then people normally use IIS, okay, Internet Information Server. The Nginx is another one. It's also very popular among Linux developers. We won't be using this one and this one. Gunicorn is something that is commonly used by Flask developers. Mongrel, Jetty, these are also a popular web server servers. Okay, so we can go and run on any of them depending on which technology we're using. But in this particular class, we'll be talking about Apache 2. Unfortunately, we will not talk about its configuration. Again, it's beyond the scope of our lecture. What we'll do is we'll basically understand how to run it, okay, and how to place our web documents inside this Apache 2 web server. Okay, so what is a web browser? Web browser is the other part of the equation. It is the client, right? The server part is a web server and it has to respond to the requests. It has to understand HTTP requests and generate HTTP responses. But who is going to generate the HTTP requests? And who is going to process the HTTP responses? Of course, it is your web browser. And I'm pretty sure you know what browser is. Your browser is a simple application that on your computer, you can open it, you can type in some URL into the address bar, and then press enter. And what the browser does, the browser goes and generates an HTTP request and sends it to your web browser. Web server, and web server generates you an HTTP response, and the browser can go and process it. There are a lot of different browsers. Google Chrome is the one that we will be using, but again, there are many you can go and use. By the way, this is the first web page that has been developed by Sir Thomas Berners-Lee. As you can see, it contains a lot of hyperlinks. So what Tom Berners-Lee was actually thinking is, okay, let's go and create such a web where every document has its referencing to each other. So, and then we can kind of look into this world and say, okay, humanity is saved because we have all our knowledges, okay, all our pieces of knowledge interlinked to each other. Okay, that was a grand idea. It was at that time. Right now, it might seem very, very simple and intuitive, but back at then, okay, when you have all your things, all your books, everything is interlinked to each other into a web. It was a grand idea, and for that, he's actually appreciated among computer scientists, and for that, he got his title of a Sir. Okay. So let's talk about HTTP now. Okay, so HTTP is an application level protocol, as I said earlier, and it is meant for transporting web documents over the internet. So it's moving one web document from one place to another place, right? And HTTP is a client-server protocol, so it presumes that there is a client and there is also a server, okay, which is basically serving those documents back to the client, okay. So HTTP is a connectionless protocol. So what does it really mean is that because it's a client-server architecture, the client is the one which initiates the communication. So it is the one which goes and pulls the information from the server, and the server is responsible for pushing the information. The server is responsible for providing this information back to the client. So in other words, the server cannot go and initiate a communication with a particular client on its own. It cannot push information to the client, okay, using the HTTP protocol. HTTP is also a stateless protocol, which means that every request is self-contained, doesn't care about the previous request. So every time the client is sending a request, it doesn't know what request has been sent before and what will be in the future as well, of course. So every request should be dealt in separately by the server. Okay, so it doesn't maintain any particular state. So two computers working on an HTTP protocol, they don't have to maintain a state. Yeah, we'll talk about the state later on, and there is a need for maintaining a certain level of state in these two computers, and we'll talk about how can we go and kind of override this limitation of the HTTP protocol through something called cookies and sessions. But the point here is, okay, the HTML in its original form, it's a stateless protocol. It's not meant for like a subsequent communication. Like, for example, the SMTP protocol is a stateful protocol because, like, every comment that you send, okay, between the nodes has a particular order, so you cannot send it one particular comment before sending the other one. Okay, so you need to know what comments you've sent before, and you got an acknowledgement from the receiving party, okay, before going and sending this particular request, right? So there is, like, you have to maintain certain level of kind of track of the comments, the request that you sent to the server. In HTTP, this is not the case. It doesn't matter which request you're sending and what requests have been sent before. Another important thing about HTTP is that HTTP is a media-independent protocol, so it doesn't mean it doesn't care what kind of resource it carries with it. Okay, so you can always negotiate the type of content that you're sending over the HTTP. You can send HTML, you can send CSS, you can send images, you can send files, you can send any type of media, okay, over the HTTP protocol. And the specifications for the HTTP protocol are given in the RFC 26 and 16 by the the consortium that actually specifies those standards. Okay, so we're not going to get into the details of the specifications, but you can always Google it and then find out that in detail all the specifications of the HTTP protocol. Okay, so how does it work? As I said, there is a web browser and there is some web server, or you can call it HTTP server, web server. What does it do? Okay, your client, HTTP client, your web browser goes and compiles in some HTTP request, and then your server generates a response, some message, okay, some textual message back to the client. So this way, your client gets whatever he was requesting and then processes it. Okay, it's a pretty simple and straightforward task. So what happens every time you go and let's say open the browser and then type in some URL into the address bar, let's say something like that. There will be some host and there's a port as well, and the port is something that indicates the application that is running, okay, on a remote computer. So by default it is 80. So 80 represents the port number for the web server. So when you're sending a particular message to a remote program running on a remote computer, you have to indicate its port number because they communicate over the socket connection, and socket connections are they use ports to identify applications running, okay, on remote computers, or it could be running on the same computer. It doesn't matter. My point is, two independent programs can talk to each other through ports, right? Through the socket connection. So you specify, oh, I want to talk to a web server. The client says, I want to talk to a web server. So that's why I'm saying, okay, I'm going to send that to a port number 80. It's a default port for a web server. The host identifies, the host is normally some domain name, and again, mapped to a particular IP address, but the host is normally some computer that is running that web server, right? And you normally say HTTP because you're using an HTTP protocol. Then you've got a path and the file, right? So you just type in this particular URL. So what the browser will do, the browser goes and compiles an HTTP GET request message, and it looks like something like this. Okay, it looks like this. You can see that there is a HTTP comment called GET, which means normally for the web server that you want that resource that is given in this path, right? So they give the path here, and then you indicate the type of protocol they're going to use, or you understand. So your web server goes and generates a response according to the specifications of this protocol. There's also another important part of this particular request. It is called the request header, and in the request header, you're going to specify through which domain you're trying to generate this particular request. The idea why you need to send this particular information to the server is because one web server can contain multiple websites, and can be mapped to multiple domain names, and based on whichever domain name you use, the web server can decide which folder to look at, and then map your virtual path to actual physical path on that folder that is located on that server computer, right? So by host, you can go and specify uniquely, okay, which website you're actually addressing at, and then the resource in the which website you want to get, okay? So your browser will go and create this particular request message, and the server goes and processes this request message, HTTP request message, goes and finds the corresponding file in that particular folder that is mapped to this particular domain name, and then goes and generates an HTTP response, okay? And this HTTP response looks something similar to this. So it has the first line, it's the response line. In the response line, you're going to see that the first thing is the HTTP protocols version, and then the status code. So this status code has these status codes have certain meanings, right? So for the client, so if the server is sending 200, that means that the resource that you're requesting for has actually is found by the server, and now the server is duly sending you that request response, the content of the resource in its response, right? And okay, some sort of a human readable message that corresponds to this status code. So it means, okay, I found that, and you can find it inside this response message. So it is a textual file, a textual content that is sent back to the client, and the client gets and receives this particular message, and it can go and read the message and then display whichever website you want to access. Okay, so let me go and show you one example. Okay, so for example, I would like to go and access this particular URL. So what happens if I go and let me go and okay, so let me go and create open a new window and copy this URL here. And let me open the my browser. This is a Chrome browser, and inside the Chrome, oops, not the settings, sorry. Open the More Tools and the Developer Tools. So if I open it, it is going to show me. Let me just go and put it here. So let me clear everything here. So if I go and put this URL here, unfortunately this URL is not working. Let me go and type in some other URL. So for example, example.com. Right, so this is just a simple URL. I can go and press. Wait a sec. I have an internet connection problem. Let me go and connect to the internet. Now I got it. So I can. Yeah, this is not working. So I can go and say example.com, and I can see this page, right? So let's go and try to understand what is actually happening behind the scenes. Okay, if I go to the network tab of my developing tools in Chrome, I can see the entire communication between client and the browser here. So I can see the actual request. So I can see that the browser sent this request. So and if I go and click this particular request and click this headers, I can see what sort of HTTP request the browser actually sent to the server. So I can see that the browser actually established a connection with this particular IP address at this port, right? So it got resolved, and then it's sent through this. So it went on and then established the socket connection through this IP address, and then through that socket it went and sent this message. You can see it's just a textual message. So it has, yeah, wait a sec. It has the first line of this message is get / something familiar we saw in the slides and the version, and the second thing is the host, and host is basically the domain name, which tells that I'm accessing this website. This is the name of the domain name of the website, and I want to find the resource that is at the root of this website's homepage. And it contains some additional HTTP headers. So what are these HTTP headers? You can see these HTTP headers as key value pairs. So there's a key and then the semicolon and then the value. So the key value is delimited by this new not semicolon, sorry, colon that separates the key from the value, right? So, and also you can see that every HTTP header and including the status line is delimited by the new line character. So this new line makes it for us to read this message easily, but for the computer it doesn't matter which delimiter you use to separate these pieces of the protocol. So the new line has a particular meaning in this protocol, in this text-based protocol. So it separates every line of part of the request. So it has one part which contains the HTTP comment, the path, and the protocol version, and then HTTP headers, request headers, which contain additional information about this request or about the client which generated this request. You can see the client is normally the information about the client is normally passed as user agent, and then the name of the browser or its engine, in fact, that generated this request. So you can see that's a Chrome and something like that. So the server knows who is generating this message request, and it can go and generate a response that this client would understand. It can also tell about what sort of content it is. It can read, it can understand, right? You can see this */*. This means, okay, this browser is capable of understanding any type of media. So it can understand HTML, it can understand XML, it can understand images, okay, and it can understand everything, okay. So you can go and specify all those things here. It can also understand encodings, like the content can be sent in a compressed way, and the browser can go and decompress the content and then display that. It can also understand these languages, so the content can be generated in these human languages as well. So it's pretty straightforward to understand and read the information that we are sending to the server. So what have we received back from this for this request? So this is what we received. We received this response. Okay, this is the heading of the response. There is a body as well. The body is not displayed here. I'll show you where is the body. So we can go and see that it contains the response line. The response line says, okay, 200, I found this particular resource. Again, the server is saying, I found this resource, and now you can find it in the body of this HTTP response. Okay, but it also gives you some response headers, which give you additional information about the content, the resource that you're asking. Okay, so it says this particular resource has been requested at in this time. Time is a UTC time. The Greenwich Meridian time, and this particular resource is going to expire at this moment, at this day, in this day. And when this resource has been modified, the date of modification, what is the name of the server who generated this, the software that generated this particular response, and so forth. And the content type, which is very important for the browser. Why? Because if you say instead of HTML, I'm sending you an XML, then the browser is going to run its XML reader, okay? XML reader to show you the content that is sent in the response. If you say HTML, then the browser is going to run its HTML renderer to render that textual data and shows you this particular nice looking website, right? So again, it depends. Okay, you're telling to the browser what sort of content you're sending, and the browser knows how to parse that content and display, or what is the behavior, what is the default behavior for that particular content. If it's a PDF file, for example, then it is perhaps going to show you a pop-up dialog which asks you whether you want to save this content to your hard drive, something like that. If it's an HTML, it knows how to read HTML and basically shows you the HTML in this way, right? And it says, okay, the content has been actually zipped and something like that. Okay, so this is the basic communication, and you can see that this communication is happening behind the scenes. And by the way, okay, where is the body of this response? Okay, the response must contain the header and the body. So body is not included here. You can go and look into the body by clicking this response tab here, and you're going to see the body of this response is just some HTML text. It contains the HTML text, and this HTML text is now displayed to you in your browser like this. Okay, so let's go ahead and continue with with our journey into the HTTP. So this is the typical request that the browser would generate for this particular URL, but we weren't able to run this URL because apparently this URL doesn't exist. But the point is, the browser doesn't care whether it exists or not. It simply goes and generates this request and then sends it over the socket to the server. And the server is responsible for generating a response. Okay, by the way, let's go and try that again. So this is what normally the response would look like. As I said, this is the response line, and it contains a bunch of data, and content type is very important. It tells that it is sending an HTML. And note that there is a blank line that separates the request head from the request body. And inside the request body, we got some HTML. Okay, so just two blank lines then just make that denote the end of the message. So one blank line just separates these. The second one actually tells that the message has ended. So that's how the HTTP server or HTTP client will know that the message has ended. So now it has to go and process that message in its own way. Okay, so by the way, yeah, these are the different types. But by the way, let's go and see what kind of response I will get from the server for asking a non-existing resource. Let me go and copy that. And let me clear everything here. So I'll go and clear it so that there's nothing here. So I'll go, and this is a non-existing resource, right? So see that some page like this here, right? So let me go and yeah. It's not showing that, but yeah, we're gonna do it with other things. Let's go and say something, I don't know, something non-existing. I'm pretty sure there's nothing such. Oh goodness. Okay, so let's go and try to do with the same thing with the example.com. Let me go and put something slash and then say, I don't know, admin and then index.html, something like that, right? So I don't know whether this resource actually exists there or not. I think it won't exist. And okay, good. What we got, what we want. Okay, so this we look into what we sent here. We are sending again another GET request to the server, and then this is the path the path to the resource that we would like to download. But look what server is saying back. It is giving a different status code. It's saying 404 not found. So the server is saying, okay, the resource is not found. I cannot find this resource, and I'm sending you back this message. Okay. So, and then also as a result, it basically shows you the same message, okay, the same page, but okay, it's still sending you some content, but okay, again, its response, it's sending you the content, but the status is different now. The status is not 200, it's 404. This is not the resource that you are looking for. It is not found, and the client knows that it's not found, and it's basically you see it's highlighting it, but it's still going and rendering you the content HTML that is being sent to you. Okay, so most of the times you get 404, okay, and the HTML will correspond to 404 message. So it says, okay, this find is not there, something like that. It's going to give you that message. Okay, good. So yeah, so this is we talked about that, and the content types, as I said, there could be a lot of different content types your browser can understand. The basic one is the text HTML, but it can be image. These are sometimes called the MIME types or multimedia types. And the multimedia types can be, again, as I said, can be negotiated. The type of the content that you're sending or requesting using HTTP can be negotiated through this content type header. So HTTP messages, they have a common structure, right? So any HTTP message, whether it's a request or response, it has the message header and it has the message body. Message body contains the cargo, the payload, right? Things that you'd like to transport. Okay, and the message header contains some the command. Okay, the command that you would, if it's a request, it's a command, or if it's a response, then it's a status. And then some meta information about your request, right? Some metadata. And this is separated by the blank line. Okay, so if we look into the anatomy of the HTTP request message, then the first line, as I said, is a request line, and the request line is it contains the comment, HTTP comment, and the resource that you would like to get, and it contains the additional information. There's a blank line separates it, and the request body. It can be optional too. Why? In the GET request, we are not sending any payload to the server, but sometimes when we, let's say, submit a form, we fill in the data and then press submit button, we are actually sending some data to the server. So this payload section will be used for this request. The payload section will be used to carry information from the user to the server. Okay, so not all the time we use this payload section, but sometime we may need this payload section to carry the data from the client to the server. Most of the times, we will use this payload section, when we are getting something from the resource, right? From the server. But server is also not some kind of, there are set requests where server is not meant to send any payload to us. Okay, but this is also optional. It's not compulsory for the server to put something into the payload section. So look into this response message. Again, it has the first line. The first line is the status line, the status for your request. What is the status? And the response header contains all the meta information about the requested resource. And there is a blank line which separates the header, message header, from the message body. And the body contains the payload, the resource that you are looking for, that you're downloading. Okay, so I can go and send data like this. Okay, I'm sending this, and I can go and, whether it's a GET or doesn't matter, I can go and send in the body some messages like this. This is called a URL encoded data. So it's a key value pair, as you can see. It has the key and the value, and this way I can go and send values to the server as well, like the various variables. So we're going to talk about that. We talk about PHP, but the idea is I can pass any sort of text into this body, right? And then it's the responsibility of the server to parse this text and read the values according to the way how I encoded them, right? So here in this case, I'm URL encoding. It's a particular way of encoding things. We're going to discuss about this way of encoding things later on. So now the server is sending back information. Okay, this is the status code, status line, and then the headers, and then the body itself, right? So there are a lot of different HTTP request comments or request methods. You can call them comments or methods as well. GET is the commonly used one. It is used for getting a particular resource from the server. Okay. Again, you can map anything, any action on the server end to this particular method. It doesn't, let's say, force you to use GET only for getting a resource from their server. You can go and use GET for anything else. But again, by default, GET HTTP method means going and grabbing the resource from the server and putting it into the server, into the client. Okay, so every time you go and click a link, or most of the time if you click a link, hyperlink, or you type in something into the address bar, the browser goes and issues a GET request. There are other HTTP methods as well. For example, the HTTP head method is the same as GET method, but instead of sending you the body, okay, the response body, the content of the resource that you are trying to obtain, it basically sends you the headers, response headers. So basically, you get a meta tag about the existing resource. I mean, you can check if the resource exists in the in this particular URL or not by sending a head request, right? So the head request kind of is something that you can use for checking if the resource exists. If it exists, then you'll get 200 status code, and then but you don't get the resource itself. You just know some additional information about this resource. There are many other methods like post, put, delete, trace. Post is commonly used for sending data, for posting data to the web server. Put is asking this web server to store some data, not just merely sending something to the web server, but you want to store it, like it could be a file or it could be some data that you'd like to store somewhere on the web server. So you can ask the server to put a particular thing, so you can send a put request. And delete is something I can ask the server to delete. Obviously it's not something that you can, like, if you go and send a delete request to a server, it doesn't mean that the server will go and delete that for you. It's just, it could be not enabled at all. So if you would like to know what kind of HTTP request methods you can send to that particular endpoint, to that particular URL, you can go and send the options request. The options will return you the valid HTTP methods that the web server accepts at that particular endpoint. So again, those methods, all of these methods are in fact just some actions that can be mapped on the web server, and there is a default behavior for those actions, but you can go and remap them to your own custom actions as well. And we'll be doing those things when we start doing server-side programming. Okay, good. So as I said, the HTTP requests are sent through the socket connection, and in Windows you can go and establish a socket connection using a special utility called Telnet. So the Telnet is something you can use, in Windows or in your in Mac or any application. So let me go and open the command line on my Windows computer, and show you that I can go and make a socket connection and then send through this socket connection some message and the data. So for example, I can go and say telnet, and the example.com is the domain name, and I'd like to connect to this port, through the port number 80, right? So I go and say 80. So now I got connected to this. So it got lost. Wait a sec. So I can say telnet, and inside the telnet I can say open, right? And 127. Sorry, not 127. Example.com and 80. So it goes and establishes a connection. It's connecting, right? So I can go and press enter here, and so now I can go and type in get, for example, the slash and then HTTP, the protocol. It's dropping the connection for some reason, but let me go and try that again. I say get HTTP 101. The common. Wait a second. Say get slash HTTP 1.1, and then I say host, and then I say example.com, and I say accept, and then colon, and the star, this one. I accept everything, and there is a blank line. I put the blank line, and what I got is the response itself. So this is my response, right? You can look into the response. It's just coming over the socket to me. So this is just pure HTTP request sent over the socket, and then that is the text that I received. It's just everything is a terminal. Again, you might see like it's not in a nice and looking way, but this is what it is. I'm receiving that particular message. It's giving me 200. Okay, this is a socket connection, and I can see all the information here, and I can see after the one blank line, I can see the entire body of this response here. Okay, so again, using Telnet is kind of a bit messy to make all that stuff, but just to show you, to prove that I can go and send those things over the socket, and I can get everything back. Okay, like this message, and this message is in fact the HTTP response. Okay, that I received from the server. It's generated by that, like this. Okay, so you can go and implement, if you know how to use sockets, you can go and try to implement similar app which sends this HTTP GET request as a text according to the protocol, and see what you get back, right? So it will be very, very interesting thing to experiment. Okay, so yeah, and okay, we talked about the request methods, but we also have the other part of the equation, which is the responses. Again, then the first line of the response is the status line, and you might get different status codes. Okay, for example, if the status code starts with 2, it means that your request was successful. Like if you were requesting for a particular resource to be grabbed from the computer, then it will be 200 will actually mean that okay, 201 is mostly like if you're sending some data to the server, then it basically says yes, I received the data correctly, no problems with that. So okay, 2 means anything that starts with 2 means okay, I received your request and I was able to process it correctly. The server is sending you the OK message or okay any other message. There are other status lines, status codes as well. For example, one is mostly like informational. Let's say server is doing something, and then like server wants to inform you with an additional things that you might want to get back to your request. Okay, so it might go and send you some status codes like starting with 1, like for example 100 means continue. Let's say you're sending things by pieces, by requests, and the server got the first piece, so it wants to get the second piece. So instead of like, you can go and say continue, so you can go and send the second piece of your request, and so forth. It's like kind of mimicking the way how like stateful protocols work. But most commonly, this is not commonly used. In my practice, I haven't seen a status code which returned anything with 100. The most popular status codes that you commonly see is these ones. Things that start with 3 actually mean a redirection. So what is a redirection? Redirection is telling the client that the request the client is looking for is not in that particular location. It has been moved to other location. So you are kind of informing the browser about the change of the location of that resource. Okay, so you're not sending the actual resource, you're telling the client to send another HTTP request to the new address of that resource. So that it means redirection. So once the client receives such response, it goes and looks into the special header, which is called the location header. So there is a location header there. So let me go and show you that location header. For example, I can go. This is my window. Let me go and say inha.us, for example, right? So if I say inha.us, yeah, I got everything as usual, and yeah, I didn't get any redirection, unfortunately. Yeah, but maybe I will get it here. Again, I cannot guess what request will cause a redirection, but okay, let me go and click this link. Okay, so when I click this link, the browser is going to issue a new request to a different domain. You can see the address here. It's iana.org. Okay, it's going to send another HTTP request to this to a different computer. So let me go and do that. Oh, finally I received a different response. So what I was trying to do is I was trying to request this particular URL, and then basically you can see what I sent. I sent the GET request to this particular URL, right? And this is all the HTTP request headers I sent along with my request. And what I get in response, okay, I got 301, this status code as a response to my message. Okay, so what does this 301 means? 301 means that this particular resource, the resource that I was looking for, is now moved. It moved to a different location. So to which location it got moved? Okay, I know that from a response header called location. This location response header tells me the new place where this URL got moved. Okay, it moved to this place. So now look what my browser is doing automatically. My browser is sending another HTTP request, okay, automatically to this particular URL, okay, and it's happening, all of that happening behind the scenes. Now I can look into this. Oh, finally I got 200. I received this resource, and now I don't, and then now I just need to go and send requests for the other things that are referenced in this particular page. You can see that some CSS files are referenced, some other files like images and all that stuff are referenced. The browser needs to go and download that content as well in order to make sure that it can display this entire HTML document correctly. So it goes and sends all those requests automatically too. Again, all of these things are simple HTTP GET requests. You can see all of them are HTTP GET requests, and then for all of these requests, it's getting a 200 status code, means that it was able to go and download all those things into your computer and then display it in the right way. So this is what is happening, right? So it's getting redirected. The browser is going and issuing another request to the new location, and it's downloading what it has, and then it's downloading everything that is referenced within this particular HTML document subsequently in this particular request. So you're going to see a bunch of HTTP requests issued by the browser to make sure that you're going to see this page properly. You're going to see this image here, you see the styles and everything. All of that stuff is stored somewhere in a separate file, and all of these things are getting downloaded this way. So if you still want to know about status codes and their meaning, you can always go and check this particular URL. It gives you a good explanation about every status code and what it really means. There are also other status codes like the 404 things that start with 4. 4 means that the problem is on the client side. The client generated a wrong request. The request either that's not supported by the browser, by the web server, or the client wants to get a resource that never existed in the server, or it doesn't have, the server doesn't doesn't have that particular resource, and in this case you're going to get 404, which means that resource doesn't exist. You're going to go and see that particular error as well. Let me go and show you that here. So if I go and try to access, for example, let me clean out all the requests here. If I go and say example.com, and let me go and write down the path for non-existing resource, so admin or whatever. So if I do something like that, what I'm going to get is 404, because it's saying, I'm just sending, my browser doesn't know about that, it's just simply sending an HTTP request, this HTTP request to this particular path, and as a response, it's getting 404. So it's 404 not found. So what it tells, the client was responsible for this error, not the server. So the client actually tried to access something that doesn't exist. So, and there is the errors that start with 500. This is mostly the errors that happen on the server side, whether the server side script that is responsible for generating a response, and it kind of encountered a certain error, so it cannot generate the response, and therefore it's returning you an HTTP response with a status code starting with 500. So I'm not going to list all different status codes because it's a very long list, but you can go and refer to this URL and find out more about them. Okay, there are certain request headers. They mean different things, right? Like we said, accept is a HTTP request header that tells what the browser can support, what sort of content the browser can deal with. Okay, so if you say text/HTML, that means that you can okay, you can accept HTML documents, or if you say text/XML, then you can accept XML documents. So you can see these different MIME types, okay, different content types can be delimited with a simple comma. Accept language is whichever language the content should be generated. I mean, you can ask the server if there are multiple options like English, Russian, and I don't know, Chinese. You can specify your language of preference, and the web server will, I mean, if it has the logic implemented correctly, it will generate a content on that language. Okay, the char set is the way how you are encoding the bytes. Okay, so there are different ways of you can encode bytes into characters. Okay, so people, like, you can go and choose whichever encoding you're using, whichever character set you're using, and the browser will know how to convert the bytes that it received. Okay, if the data is being returned in the form of bytes, it knows how to read those bytes and then convert them into corresponding, okay, characters. Again, this one is the different types of encodings. You can go and use zip to zip your files, to compress them, and then to decompress them, just to save the traffic. Okay, so if your browser knows that or not. Connection is, okay, whether you want the server to disrupt the collection after sending the request, or you want or not. So in fact, like if you say keep alive, then the server will, most of the time, server will wait for a little time, and then maybe most of the time they anyway close the connection. But if you say close, then after sending you the response, the server will immediately close the connection. I mean the socket connection, and pretend that it has never received anything. Okay, so it's because it's a connectionless protocol. It doesn't have to maintain any connection, a socket connection with you as a client. Okay, if you need to send another request, you have to go and set up a new open a new socket connection and send it through that connection. Same thing goes here with the refer URL. Okay, sometimes you go and click a link, okay, and the refer URL will be the original URL from which you clicked the link. Okay, so this way the server knows from where you're coming. User agent is a HTTP header which tells you which browser actually generated the HTTP request. Content length tells you the size of your payload, okay, things that are you're sending inside the request body. Especially when you're sending a post request, you're sending some data back to the web server, so you would like to know the length of this particular request body, so server can go and counter match if it's the same size or not, so it knows when. Anyway, the server will, okay, cut your message if you send one blank line, the second blank line. So the point is, you can go and give additional information about the content that you're sending to the server. Content type, what sort of content you're sending to the server, okay, or whether it's an HTML or XML or whatever, because sometimes you send the data again, you want to inform the server about the type of the content that you're sending, whether you want the server to cache or not. Authorization is a header which contains information about username and password. It's called a basic authorization. Sometimes certain resources might require login and password, username and password before getting access. So server can go and check if this username and password is correct. Only after making sure that this username and password is correct, it's verified, it goes and generates you a corresponding response. So you can go and send the username and password. Normally this will be encoded. It's not like a plain username and password. It's encoded, and just send it. You send this information to the server. Server can go and check that. Cookie, we'll talk about cookies, but in general it is information like key value pairs, the additional information that you normally send or maintain, this one. Okay, so we'll talk about cookies. Cookies is a topic of a different lecture, but again, it's one piece of information that request can send. So again, if you want to know about all these HTTP request headers or response headers. There are also response headers that tell you additional information about the request, the resource that you're requesting. You can go and refer to these tutorials and then documentation and get more information about them. Okay, so finally, I just want to give you one clarification regarding the differences between static and the dynamic web programming. In a static web programming, your web documents are stored as static files. Okay, something that is stored and it's static, it never changes, and whenever you're requesting that particular file from the web server's job is simply go and get the file and then serve it to you in the form of HTTP response. If it's dynamic, then that particular resource that you're looking for might not even be stored in your file system, right? It can be compiled, it can be generated as upon your request. So you go and ask a particular thing from the server goes and runs a corresponding script, okay, on its own and generates you a fresh new content, and then puts this content into an HTTP response and sends it to you, so your whatever browser can go and read it and then process it. Okay, so you can go and look into this small graph on how static pages are served by the web server, and then how dynamic pages are served, especially for the PHP in the server. Again, you can see that you receive the request, the server receives the request, fetches the scripting page. Okay, I mean, whichever script that you're asking for example, login.php script. So PHP is a script that sits inside web server. So web server simply gets that script file and it contains the PHP code. So it goes and runs that PHP using the PHP preprocessor. And the result of that, I mean, it might go inside the PHP, you might go and run some SQL commands, right? So this PHP script might go and connect to your MySQL database and get the data from that database. And then once you get the data, you might generate an HTTP content. The PHP script that is responsible for generating some content. It generates the content and you give it to the web server. Web server wraps that content with HTTP response, okay, and I mean puts it into the response body along with its all meta tag, HTTP headers and the status line, and then sends it to the browser. The browser can go and further display it to you on your screen. So client-side programming, client-side scripting, and the difference between client-side scripting and server-side scripting. Okay, we'll talk about that in a more extended way. But the client-side scripting is something that runs on your browser. Okay, your browser can go and run certain scripts. Okay, and the server-side scripting is something that the scripts, the code that runs on a remote server, on somewhere on a different computer. And these kind of scripts, this code, pieces of code, are initiated every time when the client sends an HTTP request to the web server. Okay, so these are some comparison between the advantages and disadvantages of server-side scripting towards, again, client-side scripting. We're going to go and discuss about that later on in a more extended way, but there are different scripting languages, server-side scripting languages like PHP, okay, Java, and then Active, this one. Okay, hopefully that was informative, and I hope that you've learned a lot from this particular lecture. Okay, starting from the next lecture, we'll start our basic journey into the world of fundamental web programming fundamentals, which is namely HTML and CSS. Okay, see you next week. Thank you very much.